Hello, welcome to Balancing Chemical Equations. Let's take a look at what we're up to today. So a chemical equation, it's something that's like a model that shows compounds and their amounts before and after a chemical reaction. Here's an example of methane, and it reacts with 2 oxygen molecules to make 1 carbon dioxide molecule and 2 water molecules. Now we'll have other representations of this later, but I want you to understand how we get these 2's in front. So let's take a look at how we get that. Take a moment to copy these down and pause it here so you get these all, and we'll go over them. So step 1 is to get the formula equation. The formula equation is the part that is not balanced, so there's no coefficients in front. If water is present, change that H2O to HOH if you see the hydroxide ion present. That makes it very simple for you to balance. I'll show you an example of that. Balance any polyatomic ion as a whole ion. Don't split it up. If it stays the same on both sides, act like it was just one element. Balance things that only appear once on either side. Balance only one element at a time. Don't go back and forth changing the second part of the compound when you're doing the first. Free elements, so things that are just by themselves, because do those last, because you can put a coefficient in front and change the total numbers without interfering anything else. Start with the first compound and its first element, work your way towards the arrow, and you might need to backtrack on occasion. That's okay. This is why we're going to write how many we have on either side. So let's take a look at some of these examples. All right, so we've got our formula equation up here. I can see that we first have, let me get my writing utensil out. All right, so we've got NaCl, right? I have 1 sodium because there's no subscript written. I have 1 sodium because there's no subscript written. I move on to chlorine. I've currently got 1. Over here, I have 2. So in order for those to be balanced, I need to put a 2 here. So this will give me 2 chlorine. All right. I know my sodium's not done. I'm just going to continue on. Barium, I've got 1. No subscript written, I've got 1. That's balanced. NO3, that is a polyatomic ion. I see I have 2 of them because of the subscript. This is all one thing. I've got 1 of those. So I'm going to put a 2 here, which then changes the number of sodiums I have and the number of nitrates I have. So from here, I can double check my numbers, right? 2 of the sodiums, yeah, now I change that. 2 sodium, 2 sodium. 2 chlorine, 2 chlorine. 1 barium, 1 barium. 2 nitrates, 2 nitrates. This is the balanced chemical equation. Next, I have 2 carbon. Only got 1 carbon here. So I put a 2 in front. That changes it to 2 carbon. Now my carbons are balanced. 2 hydrogen. 2 hydrogen. Okay. 2 oxygen. Now I've got only oxygen in one place on the left side. I have it in 2 places on the right. So 2 times 2 is 4 oxygen in the CO2. And I have 1 in the water. Bringing those together is a total of 5 oxygen. So I go, 5 and 2. Odd number, even number. How do I make those going to be the same on either side? Well, if this was in math, we could say 5 over 2. Because 5 over 2 times 2 would be 5. We can kind of do that, but here's what we need to do first. We can write that, however, we need to multiply both sides times 2 in order to make it all integers, all whole numbers. So I'm multiplying everything over here times 2, right? This will just go away. And then the right side times 2, 4. And remember, when you don't have a coefficient, that means 1. So 2 times 1 is 2. Now this may look like a jumbled mess, but let's go back and recount. So 2 times 2 would be 4 for carbon. 2 times 2 for hydrogen would be 4. 5 times 2 for oxygen would be 10. 4 times 1 for carbon, I'll put it right down here, 4. 4 times 2 for oxygen would be 8. 2 times 2 for the hydrogen would be 4. 2 times 1 would be 2. And remember, this is our oxygen for a total of 10. So we have a total of 10 electrons for each of those. My hydrogens match, my carbons match, and this is now balanced. This comes across in what we call hydrocarbons being combusted. So this is a combustion reaction, which we'll get to the type. This is where you might have to do this technique only in these types. All right, let's come back for part 2 as we finish these up and have our final questions.